Welcome to this session on drilling optimization, execution to control. This is submodule 2 of 4, where we'll focus on how execution and control processes connect to performance improvement. Over the next slides, we'll cover review processes, documentation, well time estimation, and how iterative design-execute control cycles strengthen both learning and efficiency. In this submodule, we'll begin by looking at the different levels of review, daily operations, rig site reviews, and post-operation controls. You'll learn the purpose of each review, how they differ, and why the timing of each is critical. We'll also cover the documentation that supports these processes, daily reports, run summaries, well-designed information, and lessons learned, because without proper records, control becomes ineffective. Another key area is applying control and evaluation feedback to update the well design, so the next operation benefits from current learning. We'll move into well time estimation and non-productive time event analysis, breaking down how to filter and clean time data and how to build learning curves across multiple wells. Finally, we'll connect all these elements into a continuous improvement loop that drives better execution and performance. The first level of review is the daily operations review. This is essentially a live check on what is happening at the rig site. One major advantage is that it involves all personnel currently working on the project, and in some cases, those preparing for upcoming operations. This real-time evaluation allows issues to be identified early, and the discussion is directly focused on the day's operational requirements. However, daily reviews also carry challenges. Personalities and perceptions often influence how problems are viewed, and because the process lacks independent control, discussions may sometimes drift toward individual biases rather than objective analysis. For these reviews to be effective, supporting documentation is vital. Daily reports, time and depth logs, and reference to the current well design form the backbone of the discussion. Together, these records ensure that decisions are based on data, not just opinion. In practice, the daily operations review creates a running dialogue between the rig site team and office support, keeping execution aligned with the program while ensuring emerging risks are controlled. This sets the foundation for more structured reviews at the rig site and beyond, which we'll cover next. The second type of review is the rig site post-task or action review. Unlike the daily review, this takes place immediately after a specific operation has been completed, while the details are still fresh in everyone's mind. One advantage is that only personnel directly involved in the operation are present, which limits the influence of external perception and allows for very specific hindsight analysis. Because this review occurs at the work site, it reduces the tendency for later story building or conviction in personal interpretations. It also minimizes outside sales influence, keeping the discussion closer to the facts. However, this type of review does have limitations. The focus may be narrow, with less emphasis on broader engineering implications, and the available expertise can be limited compared to a larger forum. Additionally, there's usually no independent facilitator, which can affect objectivity. To maximize value, documentation is essential. Run summaries, rig data and logs, and the well design information must all be captured. These rig site post-task reviews provide immediate learning that can be carried into the next stage of evaluation. Building on this, the next process step expands the scope to a more formal engineering review. The third review type is the post-task, action, or regular review, which is usually held after a sequence of operations or on a scheduled basis. Unlike the rig site review, this process brings in more expertise and shifts the focus toward engineering analysis. One of the advantages is that it uses the raw information gathered at the rig site and then adds professional interpretation. With access to technical expertise and an independent meeting chair, the review gains stronger control and reduces bias. The discussion is more structured, and the engineering perspective ensures lessons are captured at a design level. However, challenges remain. Contractor sales influence can creep in, shaping perceptions, and there is always the risk of review fatigue if too many meetings are scheduled. Required documentation includes run summaries, operational logs, well design information, and importantly, rig site meeting minutes. Together, these records provide a complete chain of evidence for performance evaluation. In effect, the post-task or regular review forms the bridge between operational detail and engineering improvement. By taking rig site insights and validating them through technical review, the findings become robust enough to update designs and influence future programs. This leads us naturally into the next stage, post-operation control. The fourth and most comprehensive level is the post-operation control review. This takes place after an entire operation or well section has been completed and is designed to audit performance at a higher level. The review focuses on three main areas: efficiency and effectiveness of the operation, reliability of the reporting systems, and compliance with defined procedures. To ensure objectivity, an independent team lead is required. This avoids perception bending, where individuals may interpret results to suit their own viewpoint, and guarantees that the process is followed consistently. Another important benefit is that the review can highlight areas requiring further study, such as unusual events or unexpected performance variations. It also supports economic evaluation, helping to quantify the value delivered by the operation. Required documentation includes the end of well report, all rig data and logs, the original well program, lessons learned, and any management of change documents. Together, these ensure the review has a full picture of both planning and execution. Post-operation control closes the loop on a project, creating a reliable foundation for continuous improvement. With that framework in place, we now move toward linking control and evaluation directly into updated designs. Here we revisit the continuous improvement cycle where control, review, and evaluation feed directly back into updated well design. At the top, we see the design stage where the well program is prepared based on available offset data and engineering models. Once executed, performance is captured and reported through daily and post-operation reviews. This reporting forms the basis of control, which allows us to evaluate how closely the actual performance aligned with the plan. The evaluation step is critical as it identifies where assumptions in the original design may have been incorrect or incomplete. By feeding these insights back into the design, the next well benefits from a more refined plan. The diagram shows this loop clearly, with arrows linking design, execute, control, review, and report in a continuous cycle. Interpreting it, you can see how each stage informs the next, preventing knowledge loss between wells. In essence, this process transforms operational experience into design improvements, which is the heart of drilling optimization. With this continuous loop established, the next step is to examine well time estimation, which provides a structured way to measure and predict performance. Well, time estimation reaches its most practical stage when we move from data preparation into building forecasts. After gathering and cleaning data, we progress to the single well total time. This step consolidates clean drilling time with non-productive time to create a complete duration for one well. It gives us a baseline against which all other wells can be compared. From there, we define the learning curve. This is where the concept of experience comes into play. As operations are repeated, teams refine their processes, tools are optimized, and inefficiencies are reduced. The learning curve quantifies these improvements, showing how the total well time decreases with each successive attempt. In plain terms, it's the mathematical representation of practice makes perfect. Finally, we extend this into multi-well total time. By combining single well baselines with expected learning curve gains, we can predict how a drilling campaign will perform across a series of wells. This approach allows planners to set realistic schedules, anticipate risks, and allocate resources more effectively. If you look at the sequence in the diagram, you'll see how the flow progresses from a single well view to a curve showing improvement, and then expands into a multi-well forecast. This forms the foundation for reliable performance benchmarking. Here we reinforce the principle that control and review must consistently loop back into design updates. Notice how the diagram repeats the theme of design, execute, control, and review in sequence. The repetition is deliberate, emphasizing that this process is not a one-off event but an ongoing cycle. Each stage of review, whether daily, rig site or post-operation, adds another layer of learning. When these insights are applied collectively, the design evolves into a stronger and more reliable program. The key takeaway is that reviews only create value if the lessons they produce are actually embedded in future designs. Otherwise, the same issues are repeated from well to well. In practice, this means updating procedures, recalibrating time estimates, and adjusting risk assessments in line with observed performance. By closing the loop, the organization builds resilience and consistency across its drilling portfolio. This message also connects directly to our next slide, which shows how iterative design and execution cycles lead to sustained performance improvements. Here we see the iterative design execute control cycle applied across multiple wells. Each well follows the same sequence: design, execute, and control. With every cycle, the knowledge base expands and the organization becomes more skilled at anticipating and mitigating risks. The diagram shows wells lined up sequentially, each with the same cycle, but notice how the arrows indicate growth in knowledge and improved risk management over time. This reflects the cumulative benefit of continuous improvement. By systematically learning from each well, performance becomes more predictable, risks are reduced, and efficiency increases. This also supports better cost management, as uncertainties are progressively removed. Interpreting the chart, you can see that while each well is unique, the structured application of design and control creates a compounding advantage. Over time, this iterative approach transforms isolated experiences into a strategic capability. The key point is that improvement does not come from one review or one design adjustment, but from embedding this cycle into the company's culture. With performance improvement firmly tied to review processes, we are ready to close by revisiting the objectives we set out at the start. Let's take a moment to review the objectives we set at the beginning of this sub-module. First, we aim to understand the different review processes: daily, rig site, and post-operation. We've seen how each serves a unique purpose, from real-time evaluation to independent engineering analysis and final auditing. Second, we highlighted the importance of documentation, and we've identified the key records required at each stage, from daily reports to end-of-well reports and lessons learned. Third, we wanted to show how control and evaluation feedback updates well design, and we explored how continuous loops strengthen planning for future wells. Fourth, we examined well time estimation and NPT analysis, learning how clean time and learning curves support forecasting. Finally, we discussed how iterative cycles of design, execution, and control drive sustained performance improvement. Together, these objectives have been fully addressed, providing you with a structured framework for execution and control. That concludes sub-module 2 of 4 on execution to control. We've now covered review processes, documentation, well time estimation, and the iterative cycles that drive performance improvement. Please proceed to the short quiz to check your understanding of the material. Thank you for your attention, and I look forward to the next session.